Despite the fact that Professor Stephen Hawking died before the James Webb Space Telescope was launched, many hours of the new space telescope will be dedicated to verifying some of his theories due to the late physicist's immense space legacy. What is the multiverse theory, and will the James Webb Space Telescope finally prove Stephen Hawking's multiverse theory? One of these theories is the very last one Hawking worked on before his death, in which he argued about a multiverse theory that implies an exact copy of you existed in a parallel universe. Stephen Hawking died in 2018, more than 3.5 years after the James Webb Space Telescope was supposed to launch. This was due to several delays that stretched the launch schedule from 2007 to 2011. Following a successful launch and deployment of its components, this powerful space telescope will undergo several months of calibration and testing before settling down to work. Thanks to the large 6.5-meter giant mirror that had to be folded during launch, the telescope will be able to peer into the atmosphere of planets outside our solar system and peek through massive clouds of dust to wrangle to watch the birth of new stars and planetary systems. jwst will be able to gather and reflect light from the early universe. The universe is thought to be around 13.8 billion years old, and jwst will be able to observe light from the earliest stars and galaxies close to the Big Bang. jwst is an infrared telescope, which means it detects objects in space using infrared radiation. It will be able to observe celestial bodies such as stars, nebulae, and planets, which are too cool. According to a report conducted by an independent review board in 2018, there were 344 single-point failures or steps that needed to work for the mission to succeed. However, the telescope was tucked inside the nose of an Ariane 5 rocket and launched safely from the European Space Agency spaceport in French Guiana in December. It separated from the rocket after the launch and began unfolding about 30 minutes after the launch, according to NASA. Many astronomers are vying for time with the telescope, and the Space Telescope Science Institute, which oversees science operations on Hubble and jwst, issued a call for proposals on how they'd like to use James Webb, with 6,000 hours of observation time up for grabs. The lucky ones have now received approvals for their projects and look forward to the wealth of knowledge they will enrich with. It's time to confirm one of Hawking's most intriguing theories, the multiverse concept. With the jwst safely delivered to its location about 1 million miles away from the Earth. The theory is special because it was the last one published by the professor. In fact, the final research from the sharp mind was submitted for publication just 10 days before his death, in the paper titled A Smooth Exit from Eternal Inflation. Hawking laid out a theory on the origin of the universe that could answer a few lingering questions. But despite being his final work, the paper was actually a final look at one of his earliest theories. In fact, if the jwst eventually helps prove the existence of the multiverse, the scientists behind it will be likely candidates for a Nobel Prize. But Hawking would be ineligible because Nobel Prizes cannot be awarded posthumously. What is the multiverse theory, and what did late physicists think of it? The multiverse theory proposes that our universe, with its hundreds of billions of galaxies and nearly innumerable stars spanning tens of billions of light years, may not be the only one. Instead, there may be an entirely different universe, distantly separated from ours, and another, and so on. In fact, this mind-bending theory proposes that there may be an infinite number of universes, each with its own law of physics and collections of stars and galaxies. However, the implication of the multiverse is the existence of mirror image, or copies. Because according to logic, if there are an infinite number of universes, but a finite number of ways to arrange particles in each universe, the same patterns are destined to be repeated eventually. Which would mean that at some incredible distance, there would be an exact copy of you watching an exact replica of this video. The concept of the multiverse appears in a variety of fields of physics and philosophy, but the inflation hypothesis is the most well-known example. Inflation theory outlines a hypothetical event that occurred when our universe was extremely young, less than a second-year-old, during which time it experienced a period of tremendous expansion, inflating to become several orders of magnitude larger than its previous locations. Our universe's inflation is thought to have ended around 14 billion years ago. But because inflation does not end everywhere at the same time, it is possible that it continues in other regions. Thus, while our universe's inflation ended, inflation may have continued and continues even today in other much more distant regions. Individual universes can pinch off from larger inflating, expanding universes, resulting in an infinite sea of eternal inflation filled with numerous separate universes. In this eternal inflation scenario, each universe would emerge with its own laws of physics, particle collection, force arrangement, and fundamental constant values. This could explain why our universe has certain qualities, particularly those that are difficult to explain using basic physics, such as dark matter and the cosmological constant. According to some scientists, the most compelling evidence for the multiverse is the existence of intelligent life capable of making cosmological observations. When viewed in this light, certain aspects of our universe appear special and vital for supporting life, such as the longevity of stars, the abundance of carbon, the availability of light for photosynthesis, and the stability of complex nuclei. But all of these characteristics are typically absent if you're a Gemini. Hawking's final paper proposes a framework for understanding the universe that would make the multiverse finality countable and subject to meaningful engagement via scientific tools. Interestingly, Hawking helped develop the eternal inflation theory, which led to the idea of infinite parallel universes. But he admitted he had never been a fan of the multiverse. The usual theory of eternal inflation predicts that our universe is like an infinite fractal with a mosaic of different pocket universes, separated by an inflating ocean. The local laws of physics and chemistry can differ from one pocket universe to another, which together would form a multiverse. But I've never been a fan of the multiverse if the scale of different universes in the multiverse is large or infinite, he said in an interview. It is impossible to test the theory. Hawking and Hertog used string theory, a branch of physics that attempts to reconcile quantum physics with gravity, and Einstein's theory of relativity to come up with a new idea of eternal inflation that relies on a boundary at the beginning of time. The idea suggests that when we trace the evolution of our universe backward in time, we eventually arrive at the threshold of eternal inflation, where our familiar notion of time ceases to have any meaning. If this theory is correct, it means that other universes similar to ours could have formed at that time, and that primordial gravitational waves could have accompanied the expansion of the universe. However, this new model is still far from being proven, and physicists will need more data and a better understanding of string theory before that can be done. The report also suggests that this idea may be tested. However, current instruments at the time were insufficiently sensitive to uncover proof of this theory. But that hasn't stopped scientists from trying. Physicists could use techniques designed to monitor ripples in space-time, also known as primordial gravitational waves, that would have been formed by the universe to hunt for evidence of other universes. Other scientists have attempted to find more physical, hard evidence for the multiverse's existence. For example, if a neighboring universe happened to be nearby hours ago, it may have collided with our universe, leaving a visible imprint, which could be in the form of distortions in the cosmic microwave background, which is the light left over from the Big Bang. Let us know what you think about Hawking's hypothesis of the multiverse when the universe was 1,000,000 times smaller than it is today in the comments area below. And thank you for watching.